one point.
Yeah, but we want to know T, right?
Yes.
I saw Marcel was watching the game.
Hey, recording is in process.
Basement.
Morning, Keelan.
Good morning, Keelan.
So Keelan, we're going over the 2012 multiple guess right now. We're just doing the odd ones, and we're just doing the quick, yep, this is what you do this, this, and this, and if we get stuck on a problem, we actually do it. I'll assign the even ones some other time. We'll do some free responses in a little while. Right now, you're looking at the class. Class, say hello to Keelan.
Hi, Keelan.
Hi, Keelan.
Hello, everyone.
Hi, everyone. Yay, calculus. All right.
I got E.
You got how many?
10, which is E. Don't know if that's right.
Are we done? James, what'd you get? D. D is the correct answer. Are we good?
Yeah.
Need to go over it? Woo! Where are we now? 15? 15. Ripping it up, baby. So what's going on here? It's the derivative graph.
Graph of the derivative. All right.
F is the range.
Okay, I'd like you also to do number 15. I want to make sure we practice as much derivative graphs as possible. So 15.
What are you even supposed to do?
I remember we did one like this.
So they give you a whole bunch of stuff here, and basically they're asking you to find the value of h of 6, and the derivative at 6, and the second derivative at 6. And then compare them. Which one's the biggest, which one's the smallest.
So you basically just like integrating a lot.
Do you still have to plug the
No.
x in?
Just still have to plug the x in.
Like, because it's 0 to x?
So what does that mean when you have to integrate from 0 to x of a function? What does that mean?
0
And what are you doing with 0 to whatever they give you?
Integrating from there to there.
And what happens when you integrate from there to there? That's the area. So the integral from 0 to x is the area under the curve from 0 to x. You're looking at me like you've never heard that before.
No, I have, and I remember we did this problem. I just forget.
So how do you find the area from 0 to a certain place, like 6?
You integrate from 0 to 6.
Okay, great. We won't be able to integrate though because we don't know what that function is.
Right.
So we can, however, do what instead, which is the same thing as integrating. What did you do in the last problem?
What was the last one?
Literally the last one we did.
Did separate integrals.
And how did you do? Oh, did you actually integrate?
Mhm.
Oh, you didn't use geometry?
Mm-mm.
Okay. So if you had used geometry, which you could have for the previous problem, what would you have done?
You had a rectangle and triangle.
You'd have a rectangle and triangle. What would you do with those? Add what about them together? Their areas, right? So if you don't know the function, you can oftentimes at least find the area or something approximating the area. Yeah. So as we look at this, the integral from 0 to 6, what can we tell about that?
Area is below the x-axis.
The entire area is below the x-axis, meaning that the whole thing will be,
Negative.
and will it be a little tiny negative or a lot negative?
A lot.
That's a lot of area down there. Okay, so we know that the integral from 0 to 6 is some semi-big negative number. Is that helpful? Great. Now do the rest of the problem.
I don't get what we're supposed to do.
So there are three quantities that we're going to compare here. The function value at 6, the derivative at 6, and the second derivative at 6. Which one's the biggest, which one's the smallest, or which one's the one in the middle?
I don't get how we would go about finding that.
Okay.
So that
Um,
Like, is there any math involved, or is it just like reasoning through the problem?
Definitely more reasoning through the problem, yes. Yeah, there's no, you're right, there's no actual writing stuff down. You just go, yeah, well, the first derivative is going to be this number. The second derivative looks like it's going to be about this number. And the integral is going
was
to
that
be
head nod?
this number, about.
What did you get?
Yeah, sure, biggest.
No. Hey, Keelan.
Wait, is that recording now?
I keep forgetting.
She's very quick.
She's with
Yeah.
us.
She's like, oh god, that's what they do all the time.
She's here every day.
Yeah, I know, but she's not like turned
Yeah.
around at us every day.
Oh, that's true, yeah. Okay, so do we need help with this problem?
So let's.
All right, Keelan, don't get too dizzy. That shows the board. Okay. So the graph looks, I don't know, something like this.
I got it by the way with B.
Okay, good. So, tell us all about it.
Well, you know that when you so that's like, all it gives you is the 0 to x of f of t, and you know that when you integrate, it's the area under the curve, and then what we said earlier is, it's a lot of area under the curve, so it's going to be a big negative number, because it's under the curve, so that means
Okay, so let's just pause right there.
negative.
Does everyone get that concept?
Yeah.
That this integral here, which is really, is this h or g? H equals?
H equals
H equals, okay.
H
So h of x equals this.
Yep.
So h of 6 really means the integral from 0 to 6 of this function, which really means the area under the curve
Which
from
is-
0 to 6 of this function, which really is this big negative area. Is everyone good? Okay, so we have equals some negative number.
But that negative number is pretty small, so it's, I mean, pretty big.
Yeah.
Like, but it's negative.
And
so.
and what would be an easy, fairly easy way anyway, of approximating what this area would be here?
Ryman.
We could do Ryman,
You
just
know,
that we
you
don't
could
know
make
what
a
the...
tri- you could just make like a triangle.
We could, right? We could make a little triangle right here.
Yeah.
And figure out the area of that triangle. And we'd actually have some reasonable approximation of what that is. Right, the base would be 6, what's the height?
Or negative 4.
4, right? So it's half base times height, so 6 times 4 is 24, half of that's 12,
Negative
right?
4.
So this is approximately equal to negative 12, probably even more negative than that.
So.
Is everyone okay with that?
Yeah.
Okay, good. So what is h, I'm going to do this over here, I think Keelan can see this, h prime of 6, what does that mean?
The second derivative.
So this is the derivative of h.
Oh wait, is that
Yeah.
1?
And what is the derivative of h? F is the derivative of h. F is the derivative of h. So what is h prime of 6? In other words, what's the derivative of 6?
0.
0. Right? This is the derivative graph. The derivative at 6 is 0.
And so 0 is greater than negative 12, so that already eliminates some answers.
Good, true story. H double prime of 6, what's that mean?
The slope.
That's the slope of the derivative function at 6
And it's probably a positive 4/3.
thirds. Yeah, it looks like it's about 4
So which is greater than negative
thirds.
12, which is greater than 0. So
Okay, so this is the big one, middle, small. It's good? Okay, great. Did you get all that, Keelan? I hope so. Oh, maybe you missed a little bit of that right there.
It's Keelan, who are we kidding?
Yeah, okay.
Oh, we're not on the screen?
Just one line of it wasn't on the screen. Okay. Back to you, Bob.
We could make our own talk show.
Yeah. Calculus with Carrie.
Yeah, that's gonna be your new textbook.
So I want to call this class instead of AP Calculus. What class do you have? Calc with Carrie.
All right.
Oh,
15. We're at 17. 17.
The paper above shows the graph F.
Another 2
Not quite.
here. Oh, it's the other way.
Mm-hmm. So G is the integral of F this time.
No, wait.
Well, I'm
Yeah,
sorry.
well, you have
G is
to
the sorry, G is the
integrate
derivative of
G.
F.
Yeah.
So which of the following could be the graph of G?
So do you do the thing
Well-
where you look at some points on the top function?
Well, we see that, so if G is the derivative of F, so the graph of G is just going to represent the slope of F. So if we look at F, we can see that first of all it's linear, and second of all, so we have a positive slope,
And it,
and then, so
it's
now we have to,
constant.
so now we have to look at,
Go.
right. So that means that if the
So it's
slope
not
is
your-
constant, so if we can just kind of pick a number, so say it's 4/3.
Mm-hmm.
So the slope of this line is never gonna change, so what that means is we're gonna end up having a horizontal line representing the slope. And it's
Mhm.
gonna have to be
So
positive.
it's either A or B.
And it has to be
Above
above the
negative,
x-axis.
so it's
So, I'm sorry?
B is below
B is
the
negative.
x-axis means it's negative.
Oh, right, oh, okay. Wow. My
Tricky,
poor little
tricky.
delusional eyes saw that as, the only difference was that in B, there was an arrow at the end of it, and in A, there wasn't. But that's the axis, so, okay, good. I was like, wow, those people are being fairly picky here.
Is there a rule about arrows?
Well, in the original function of the graph of F, that graph doesn't have arrows on it, so it starts at 0 and ends at some location. So that to me was A, and then I looked at B and I'm like, really? They're gonna make them just distinguish between the arrow and the not arrow? Okay, that's, whatever. Yes, you got it, it's A, yes. Jacob's reasoning was totally correct. This is clearly a linear function. Linear function has a constant derivative. Good. All right, 17, 18, 19. 19.
So we find the derivative of F in terms of X, and then we have to set that derivative equal to a half, and, oh wait,
It gives you the slope, so you're not solving the slope.
You're almost there. So we gave us
figure
F.
out what the x and
And what do you have to do with that?
Once you figure out the x, you plug it back in, figure out the y.
Sure, but how are we gonna figure out the X? That's the part I'm,
Take the derivative, set it equal to 1/2.
do we all agree with that?
Yep.
That's going on here, right? 'Cause they give us F. Where is the derivative 1/2? That's what this question's all about. So once you find that X value, then you plug it back into the original and get the Y value. Is everyone good?
Yeah.
What method of differentiation would be used for 19?
Quotient.
Good. 21. horizontal asymptote, also known as,
In the
I
denominator,
think it's E.
Ratio.
in the denominator is degrees.
so horizontal asymptote means end behavior. Yeah?
Mm-hmm.
Okay. And so then we need to just look at these and go, oh, which one of these has an end behavior that's going to be 5? And the answer is E.
Because you go by the degrees of the top and the degrees by the bottom. If
Mhm.
the leading degree is the top, both the same on both the top and bottom, you look at the leading coefficient, which
Mhm.
is 20/4, which is 5.
How about D? Isn't that also 5?
Negative.
That's -5. Right, it says 1 minus it.
Nice.
What's going on with C? Is there asymptote there? 5?
Yeah, 0.
There's an asymptote there at 5. Why aren't we using that one?
Wrong.
Because it's wrong. Well, why is it wrong?
Yeah.
Asymptote is 0.
Is it no?
What asymptote? 0.
The horizontal asymptote.
Horizontal asymptote. But isn't there an asymptote at 5?
A vertical?
It's a vertical asymptote.
Ah.
Oh! That was a little too subtle for me. Sorry. Alright, 23.
So it's just like perfect rearranged.
With some random numbers in there.
Yeah.
Yes, there's some random numbers in there.
So we just have to know how to set it up right.
Which differential equation describes linear growth in the size of population?
Wouldn't it be A since differential and linear is just a constant?
Wouldn't it be?
It's A. So what they want to know here is which one of those things, after we integrate it, will give us a linear function for
Oh,
P.
so it'd be 200x.
Right, when we
Okay.
integrate it, yes. Does that make sense to y'all?
Mm-hmm.
Okay, great. 20,
So wait, where in there did it mean that you had to integrate?
I'm sorry?
Where in there meant that you had to integrate it? Like what function once you integrated it?
Well, it gives you the derivative of that.
Right, so all those are the derivative. And after you integrate each one of those,
Oh,
you'll end up with what function?
right, okay.
P, right? You're gonna end up with P of T. And they want P of T to be linear. 25.
Multiply dx over. Integrate. I mean, wait a minute. No, you just integrate 2 sin x. And then you need to plug in the point in order to find the plus c.
Okay, so I like your first step, which was multiply dx over, so you can integrate the right side as well as the left side. Right, you can't integrate a side unless you have a d something, right? So we're going to integrate 2 sin x. So we're going to get y equals whatever the integral of 2 sin x is, and and then there'll be a plus c, and you figure out the plus c. Please take a moment to actually do that one.
But then isn't it y squared over 2? Because it's dy.
No, we're not doing the derivative again. We're integrating.
I know, but how do you get rid of the d on that side?
We integrate.
How are we supposed to figure out plus C?
They tell you that y of p, aka, I'm sorry, y of pi equals 1, aka f of p equals 1.
F of pi.
F of pi.
I still don't understand how we're supposed to find plus C.
You're going to plug in pi for x and 1 for y, and here it seems.
Can you explain that?
So after you integrate, you're going to get something.
Yes.
So it's going to be y equals blah, 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 plus c. So for y, you're going to plug in 1. because it says y of pi equals 1. And for x, you're going to plug in pi, because it says y of pi, that is y of x, same thing. And then the only thing that is not calculated yet is c. So just do, whatever calculations you need. Anyone got an answer?
E.
I got E.
E? E. E is correct.
E.
E is an Ernie.
Ernie.
Yep, for Ernie.
Ernest.
Okay, are we good?
Mhm.
E, yeah, okay. 27. So x plus 2y times dy dx equals 2x minus y. What is the value of the second derivative at the point 3, 0?
Well, would you divide over the x plus 2y
You could do that.
and
How to
then
do the quotient rule.
quotient rule
Yeah.
and then plug in the point?
Yeah. Is everyone cool with that?
Yeah.
Awesome. Okay. Crack out your calculators.
Or look it up.
Okay,
Yes.
thanks.
So we're on 77.
Did you have a question?
Calculator.
Yes, you have a question.
Thanks.
Batteries are low. Your battery's back or is it shorted?
And battery free. Okay. Two batteries. Maybe it's batteries. Oh, my ears.
From what? Ernie?
You're right, 2 days ago. Alright, where are we now? 77. Let f be a function that is continuous on the closed interval 2 to 4. F of 2 is 10, f of 4 is 20. Which of the following is guaranteed by the intermediate value theorem?
Oh, shit.
No idea.
Mean value theorem.
Okay.
Mean value theorem. Which is when the slope is equal to the point at which it gives us.
Yes.
I forget all these terms, which is probably a bad thing.
So, which of the following is guaranteed?
So what do we got here?
So, in function on from 2 to 4.
Okay, so we got from 2 to 4, and it says f of 2 equals 10, and f of 4 equals 20. Which of the following is guaranteed by the intermediate value theorem? Okay, so this is different than the mean value theorem. Continuous in the closed interval. Okay, so 2, 10, 4, 20. And we know it's continuous. So we don't know how we got from here to here. Let's say it went like that. So we know that because we started here at 10 and ended here at 20 and it was never broken, every y value between 10 and 20 has to exist in here. Does that make sense? Because it's continuous, it's not broken. So what that means is that, well, what does that guarantee us then? Which choice?
F of x equals 13 has a solution. Or F is one solution.
F of x equals 13 has to exist somewhere.
Because between 10 and 20.
Yep.
Right?
Does that make sense?
It could also be f of 3 equals 15 though.
It doesn't guarantee that f of 3 is 15
Right.
though.
Oh wait, is this supposed to be like definitely
Yes,
guaranteed?
guaranteed.
Oh, okay.
Guaranteed. So it's possible that f of 3 is 15, but we don't know that. Is everyone okay with that?
Yep.
So while we're on it, what's the mean value theorem all about? Which is different.
Saying at some point there is a slope that is equal to the slope from the interval beginning to end.
So the mean value theorem says that if we find the slope from the beginning to the end, and we have a continuous function, somewhere between the beginning and the end, there will be a point on the curve that has the same slope. In fact, in this case, there are actually two places. Does that make sense?
Yeah.
Okay, awesome. Gail, I hope you're having fun with your horses.
She's taking her AP Lit test. Wish her luck.
What? Right now?
Yes.
Oh.
And Friday
Oh, you
she's
didn't know that's why
AP
she was out?
US History.
Oh, that's right. Yeah, I knew she was out
Good
there. I
luck,
couldn't remember why.
Keelan. I know you did great.
Okay.
AP Lit, AP History, and AP Calc.
Yeah.
I would die.
All right.
And she's in physics.
Where are we?
79.
77 is good.
You said so?
On to 79.
And like
79. Particle. Love particles.
Ooh, these are so nice. Average velocity. Nice.
Mm-hmm. So, which one of those gives you the average velocity from 0 to 80?
I was trying. You're good. Just kidding.
So can we say that this question is also asking, what is the average value of the velocity from 0 to 8?
Yeah, that's the one.
Do you know how to do that now?
B.
1 over
1 over
a b
B
minus a.
minus A times the integral from.
A to b, blah, blah, blah. Good, which one's that? That's B.
B.
Right, just a subtle change in words helps you understand that problem. Everyone's okay with 79?
Yeah.
Yeah.
Very nice. 81.
81. If the tank contained 80 gallons,
800.
800, so there's already some, that's like the plus C stuff already in there.
Okay, water pumped in the tank at a rate of blah.
So we integrate the rate from 0 to 20 to get how much was pumped in the 20 minutes, and then we have to
Add 800.
add in the 800 that was already there.
Good. How are you going to integrate that from 0 to 20?
Calculadora.
Calculadora. Right. And what's the concept there?
But you can
You
use
know
your
how-
calculator.
You know what
That you know
integrating the
that
rate
rate
means?
To get
Get.
accumulated
Value.
amount or
Amount.
value. Yes. Right. This is the rain barrel.
Can
Remember the
I?
rain barrel problem?
Yep.
There was already water in the rain barrel and we added more.
How do we do the
Math 9,
Where's math?
0 to 20, 30. You can just graph it.
Yeah, you can also just graph it.
Just graph it?
Yeah, graph it, and then you do the second calc integrate.
Can I do that real quick?
She's getting permission.
Where is she asked for permission, so.
All right, the answer is D.
Red says the answer is D. Keelan, what do you think? Okay, good.
Invalid? What the?
You're
You
invalid.
might need more parentheses.
So where's little Keelan right now, anyway?
Taking your AP test.
I know, but where do you
Miss
take?
Shev's room.
Oh, you take the test in Chev's room.
I don't think
No,
so.
I got D too.
Oh, maybe they might have moved it. Didn't you guys
Well,
take it in Miss
we,
Shev's room?
well, yeah, but we were history.
Yeah.
Right, they're gonna take her out, they're gonna
they in
take them out of an
Pender's?
English room, I bet. Maybe
Because they
Pender.
typically use like Pender, Class, and Chev.
Yeah.
We're just integrating that thing, right? Keep sending that.
Is your
Window
window not
big.
big enough?
I did the,
Integral? So
Yeah.
did you do 30 parentheses 1 minus e raised to negative
Put the X.
0.16 x
I would just distribute it.
parenthesis and then another parenthesis?
yeah.
Works more than for
It may be easier if you graph it.
I'll throw in another parenthesis and see what that does.
Are you doing the not graph? Are you
Yeah.
doing the math line? So my calculator does the same thing where it doesn't work well with when it has to distribute, so just distribute it on your own. So instead of 1 times,
Distribute.
so instead of like, instead of 30 times the quantity, 1 minus e to that, just distribute the 30, so you'll have
So
30 minus
weird.
30 e to the negative 6.16. Cause like, I did the same thing and my calculator spit out like 86, and I was like, no.
Okay.
You probably did that.
Are your ratings?
What?
Your ratings?
I'm not getting an answer.
I'm getting answer all.
No. It says quit or go to.
What did it
Do go to. It shows you all your work.
Yeah, good.
I did, and then it took me back to my thing.
Oh, really? I didn't know that.
Your window's
Let's
not
go.
big
Oh.
enough.
Start again.
That's what I used to
No,
do.
no, I was doing what Brandy did.
Oh.
Like the thing, and
I don't
then,
think there's.
Never mind,
gonna be
I was
enough
graphing.
parentheses.
Okay.
I graph. I find it
Here,
to
I'll
graph
do
it is easier.
Yeah.
Yeah,
try.
I like graphing it.
thanks, Mom.
Of course, I've never tried the other way either, so. Yeah, there's graphing. Okay, so, by the way, the correct answer is D. Anyone?
Nice.
Wait.
Yeah.
Nice.
It's way down. And since they're rude, they put in the answer for if you.
Of course. Which was, how much? 420? Yeah, nice.
Because they're really nice people.
Yep.
And they want in the future to be great. Trick me on
Your
the
future's gonna be great with or without calcium. Don't let this define you.
No, you know, your calculator's just programmed different. It's like bringing you to y1 and y2. I think it wants you to graph it.
graph it.
It hates me.
Okay, anyway.
Sorry,
we-
they will
Yeah,
not.
I think.
Let's move on to 83,
our
please.
calculator's
83.
updated.
Ooh, my elbow cracked.
You're no help.
I'm an elbow.
All right, 83. Graph above gives the velocity v in feet per second of a car, blah, 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 0 to 8 something in seconds. Of the following, which is the best estimate of the distance traveled by the car from t equals 0 until the car comes to a complete stop?
Area under the curve.
They're into the curve.
Add them all up. Get the closest answer. Move on.
Okay, great. So how are we gonna add them up anyway?
Do rhyme sum.
Basically, yeah, we got whole piles of squares there. We can just add up all the squares, right?
Yeah.
I'm just gonna do a reasonable approximation. Okay, great. My guess is that it's gonna be somewhere between C and D. It's gonna be probably one of those two. My guess.
Yeah. I would guess that.
21 times. I think it's D.
Okay. The answer is D, by the way.
Oh, I told you.
What'd you do?
Counted
Counted
the
up all the
boxes,
whole
but
boxes.
didn't count the boxes with only a little bit because I counted the boxes that were missing a little bit. So those little bit.
What
Cut them. Got
hell are you
20.
saying?
Got 21 boxes
Mhm.
times 10 for each box.
You go see like 8 times 15, it's pretty much half.
Mm-hmm. Okay, good. We're all good on that?
Mhm.
Integrate velocity, you get total distance traveled.
What did you think the answer was?
80 something else. 85. Woo! I love 85. Because
Why?
it's an F prime graph.
You're
Graph
up.
of F prime, which is the derivative of F, is shown in the figure above. The function F has a local maximum at
F.
Maximum when the slope of the
Goes
function
from
f is
positive
going.
to negative. So where does it go from positive to negative? So at positive 1, it goes from negative slope,
Positive.
positive slope to 0 to negative.
Boom, boom, boom. Correct answer is
1.
1.
See that, Eliza? I wish we were in this class.
Don't join this class. No.
What was that?
87. 87.
Oh, I skipped a page.
So f is concave down when the second derivative is negative, so second derivative is going to be negative from -2 to -1 and 1 to 3.
Is he correct?
Mm-hmm.
Yep, that's the second derivative, and the second derivative is negative when we're below the x-axis, so that's -2 to -1 and 1 to 3.
Which is E.
That's E. 89.
9.
Particles.
Oh, look, 88, they're close.
Yeah.
Okay.
Wow, it looks like just like yours.
Only better.
Particle moves along a line, so its acceleration when t is greater than or equal to 0 is given by a of t equals blah.
So you have to integrate the acceleration to get velocity
Then you use your 0.05
to get
to
C
plus c.
value. And then you plug in t equals 3. Boom, boom, boom.
Let's do it. I'm going to say this is actually more like the rain barrel.
Right, well we have a plus, because you have a plus c.
You already have a value, yeah, so, right.
Where do
I
you
don't
integrate that
understand how we're
from?
supposed to solve this.
So when you integrate a rate of change, you get an accumulated amount. So for example, when you integrate velocity, which is miles per hour,
Okay.
you'll end up with a whole bunch of miles.
So do you just integrate that regularly, or
Does that make
do
sense?
Sure.
Okay, so when you integrate rate, you get accumulated amount. Rate is really the derivative. So when you integrate the
Say that
derivative
again. Rate
of,
is what?
say that again,
Rate is what?
derivative.
Okay.
Derivative is slope is rate.
Yeah.
So when you integrate the derivative of something, you get the accumulated amount of that thing.
When you integrate the rate of something, you get the accumulated value.
Mhm.
Okay.
So for position, which is s of t, position, when we do the derivative of that, we get velocity. Does that make sense? Right, when we do the derivative, you get that. If we integrate velocity, we will get accumulated distance. Position is distance. So you integrate the thing that you took the derivative of, or you integrate the derivative, and you get an accumulated amount of this. So when you integrate velocity, you get an accumulated amount of position. Does that make sense? Ish. Same concept applies.
we solve for du or dx?
When we do integral of a of t, the acceleration. When we integrate acceleration, we get accumulated velocity.
Okay.
They give us the acceleration function. So we're going to integrate that, and that will give us our accumulated increase in velocity.
All right. But there's like more stuff to the problem.
A very small amount.
if the particle's velocity at t equals 0 is 5, what's the velocity of the particle at t equals 3?
So, what's happening is, we already are going 5, whatever it is, feet per second, I'm not sure what the units are, but whatever they are. We're already going that fast. When we integrate from 0 to 3, we're going to add on some more speed. So you're just going to integrate from 0 to 3 to find out how much more speed you added on, how much more velocity you added on, and you're going to actually literally add that on to the 5 that you started with.
How do we know that we're integrating from 0 to 3?
Because it says, what is the velocity at time t equals 3?
How do I know we start at 0?
Because it says t is greater than or equal to 0.
Okay.
Those are fair. So this is the rain barrel.
Alright, I'm really confused because when you plug 0 in, a lot of things just, everything just goes bye-bye.
Right. So treat this like the rain barrel.
I did.
You already got 5. You're already going 5 feet per second or miles per hour or whatever it is. And then you're just going to add on to that the integral from 0 to 3 of a of t. You do this with your calculadora and then add 5.
Wait, how did you know it was 0 to 3?
You have to go from greater than or equal to 0, that's t, and then it says at t equals 3.
Do you do anything with the 5?
Yes. Right. Do you remember the rain barrel problem?
Yeah.
We already had some water in the rain
You
barrel.
add the 5.
That's right.
Sorry.
I
Yep.
think I know how to do it.
I know how to do it,
Mhm.
but my integrating, I'm like confused
Do you have-
with where I'm lost.
Don't integrate, just use your calculator. Just, however you choose to integrate, I like to graph, so that'd be the method I would use. I could graph that thing and then,
Ooh, the answer's E.
This may sound like a dumb question,
Mhm.
but how do you use your calculator to solve this?
Okay.
Like, not the way that Brandy did.
graph it.
So go to y equals, plug in this, and you graph it, second calc. Go to 7, told you this for you. Put in your lower limit, which is 0. Your upper limit, which is 3. We'll do this thing, and do this,
Sweet.
and then you can plus add 5.
Well, you get 6.710, and then you add 5. Do you do it the graphing way?
Yeah.
And I have no clue how to do it.
Put it up, so, lower limit, 0.
0 to 3.
3?
Yep.
I have 3.
Which is like half of mine, so.
Then you add 5. Not 5, that's like 8.
No, it's supposed to be how much? 11 point something.
I got 11 point something on that. That's fine.
Okay.
Wow, I didn't even leave her at 6 o'clock this morning.
Do I have to make composites or something?
Thank you.
In the numerator, you have x plus 1 instead of x plus 3.
Right, blue one.
That'll do it.
Okay.
Which is kind of interesting.
Basically, because
What color is your shirt?
white,
What's white for me?
white,
Same.
we're the same person. And I have socks as well.
I have kettle socks. Oh, what are you wearing them already?
Jay, did you get it?
Back to white in no time.
No.
Are we ready to move on to 91?
Yes, sir.
Did we all get it? Okay, 91.
Wait, did someone say no?
I don't know, does anyone say no? Are we all set getting this?
Just wanna make sure.
Okay. 91. So we're given an F prime table instead of an F prime graph.
Well, you see that it goes from 3 to 1, which is negative, because it's going lower,
Mm-hmm.
okay? And then it goes up to 4 and 7, but then back down to 5.
So what I would actually do is I would graph this.
Graph it.
We are, in my opinion, quite familiar with F prime graphs. We've done a nice job with those. So I would graph this smoothly, right? Don't make it into points and stuff like that.
Wait, or do you want me to plug that into my Y editor?
No. No, just make a sketch of it.
Oh.
So at -2, plot 3, 0, 1, 3, 4, 5, 7, 6, 5. You know, it's a fairly quick and simple plot. And remember that that's the F prime graph. And then analyze the F prime graph the way we have been recently.
I don't get this whole F prime graph thing.
So ordinarily, when we graph something, we're just given the graph of the function. Just generally what we do.
Yeah.
Here, they like to give you the derivative, the graph of the derivative,
Okay.
and then make you figure out stuff about the original function from its derivative.
Okay.
Does that make sense?
Yes.
Okay. So that's a big theme here on the test.
I
Yeah.
think it has at least 2 points of inflection because the direction changes twice.
Why would it only have 2 points of inflection?
What?
Why doesn't it only have 2 points of inflection? It says at least, right?
Right.
Why doesn't it have exactly 2?
Because there could be more out of the magnitude. Or in between the numbers, it could like go like this, but it's not changing
Right,
direction.
exactly.
See, it's usually possible.
Was that the right answer?
Yeah.
Wow, that was the last question, everybody. Surprise!
I know.
Why wouldn't it be, like, I get why it's B, but why couldn't it be E? To relative extrema, at least.
Because relative extrema for F prime graphs.
Okay.
Oh, good, thank you. So actually, in terms of the derivative, where do extrema happen in terms of the derivative? When the first derivative is, where do maxes and mins occur?
Hills and valleys.
Hills and valleys, where do those occur
Keeps vibrating every hour.
in terms of the derivative?
I don't know what you're trying to get me to say.
Yep. So when you look at a hill or a valley,
Oh, the slope is 0.
good, the first root is equal to 0. Yeah?
Yeah.
Okay. So when we draw an F prime graph,
Where are you going?
we'll say that this is an F prime graph. So we know that at this location here, what's the derivative? 0.
Why?
Because this is the F prime graph. And what's the value of F prime at this location? 0. It's on the x-axis, it's 0. Right, we're not looking at slope. That's the mind bend of the F prime graph. Right? If this was just a regular graph, I'll just draw a slightly different graph. Right? And I say, hey, what's F prime right here? You're gonna tell me, oh, I don't know. Looks like about 4/3, right? It's a positive slope. Yeah? And this is f of x. You're used to looking at f of x. I'm actually giving you the derivative. Taking the work out of this. You don't have to figure out what the slope is. You just need to tell me what's the value here. This is the f prime graph. It is the derivative. At this location, the derivative is 0. At this location, the derivative is 1. At this location, I hope I did it right, the derivative is 2. at this location, the derivative is negative something. Right, here we are. What's the y value down here? Negative 2. I don't know. Yeah? So all you need to do is look at the value on the f prime graph, and you have the derivative that you need. So, when is there a maximum or a minimum? When the first derivative is?
0.
When the f prime graph is?
0.
Where it crosses the?
X-axis.
Okay, so we're going to have a max or a min here and here. Those are the only places we can have maxes and mins. And we know that f prime, the derivative, goes from negative, below the x-axis, to 0 to positive. So what does that look like? It looks like this. Negative, 0, positive. That's a minimum.
Okay.
Over here, it goes from positive to 0 to negative. That'll be a maximum. Is that good?
Yeah.
Okay. So I don't know what their graph looks like. It probably looks, I think Brandy said it started high, went low. Did that maybe?
Pretty much.
Yep. So it looks like it has two extrema, a minimum here and a maximum there. But this isn't the function. This is the derivative of the function. Okay? Okay. Was that the last of the multiple guess?
Yeah.
Nice. Okay, awesome. And 2. Good. Okay, so question. How are we feeling about the multiple guess right now? So far? Pretty good? Okay. Yeah, I'm feeling pretty good about it. But that does not mean we go, got this. Because we don't. Right? Let's make sure we're totally clear on this and nail it down.
I have a question about the test.
Yes?
So one of my friends told me that their teacher told them that like it's curve, like the AP tests are graded on a curve. So like if everybody thought it was really easy and every single person got a 5, like they base your score off like you could still have gotten like a 4. Is that true?
I would say that it's partially true. They adjust the cutoffs, is what they're called, year to year. So
Does it depend on how the students do though?
to a certain extent, yes. If the average score is like you get 30%, they'll adjust it a little bit. They're not going to say, oh, you got 30%, that's passing. They're not going to do that. So it's generally somewhere between 45 and 50% gets you a passing grade with the points. Generally what happens for us, our group here, is we do a little bit better in the multiple choice, a little bit less good in the free response, and it comes out together and we do fine. I think this year, because we've really done a nice job, I think, of figuring out which ones are the ones that are likely to be asked, these are the types, and we're really nailing down the types, I think we're going to do well in both parts. Again, I don't want you to get cocky and go, got this.
I don't think I'd ever say that.
Right?
I don't think I can say
Right?
that.
Okay, good. I just don't want you to get to that place, because then you get complacent and you don't do your stuff, and then you're effed.
Yeah, I was just wondering, 'cause
Yep.
I thought that was weird.
Yeah, no, it does adjust a little bit. So 45 to 50% is where we go in order to get our cutoffs. So, all right, great. Hey, let's do some multiple. No, we just did multiple guess. Free response.
Do we have?
We have free response. Yeah, let's go to.
Oh, okay.
We did 2012 yesterday.
Yes.
Yeah. So let's do 2013.
Yester class?
Yester class. Actually, we did it during advisory.
Oh wait, what the heck?
Advisory and like.
No, and the Chromebook.
Nobody brings their Chromebook charger ever.
Come on, man.
How are we supposed to get these problems?
Never got it back.
It's on Coxsone.
I always carry mine.
Commerce to eat.
What?
Commerce to eat in Spanish.
Comares to eat?
That Quizlet's on your thing.
Oh, good, thank you. So little Soph made a Quizlet yesterday, or at least began a Quizlet. I don't know how far you got into it.
You put
Did it's all done? Okay. So what she did is took the review pages from this calculus review book here. Key derivative formulas, key limits, key integrals, key formulas in terms of applications, average values, stuff like that for integrals, etc., etc. Put all those on a Quizlet.
Where's this Quizlet?
Tell me how to make a Quizlet, or how to
Can you
get to
put
it.
it on classroom?
I put it in the classroom? All right, let's
Where
go
are we
to,
going?
so I'll do that in just a moment. So we're gonna go to 2013.
Wait, I clicked on the link, but it's 2016.
You
Okay.
clicked on the
Yeah,
There's
so go to a previous link.
Three, it was posted, yeah, April 28th. Survey response, practice questions, dot, 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 dot.
See the link.
Yeah,
this one?
See the link.
okay. So, 2013 is what we're looking at here. Let me tell you the ones I want us to do.
Free response, 2013. Do you want the free response questions?
Yeah, that'll do.
I just want to look at the answers.
The scoring guide.
Come on, man.
M&M.
Yeah.
Is
Is that for your guys' catapult?
Yeah,
for?
come on.
Algebra 2, they make catapults.
This is so frustrating. I made this whole list, year by year. It was literally on my desk this morning. I saw it this morning.
Is it under your laptop? I got you.
All right,
Right there.
2013. So we want to make sure we're doing a data table, an F prime graph, and an area volume and a differential equation. So that's 3, 4, 5, 6. So let's start on 3. Actually, we haven't done a particle free response, I don't think. Let's do the particle free response as number 2.
Back to 2.
Back to 2. Okay, got that. I'll post the Quizlet.
If I put this right here, Jake, can you see it?
Yes.
Can't see it.
See what?
Like if
Oh,
it's
there,
in stuff,
there's
or like call it behind.
So I just post the link to the
Like
Quizlet?
grabs it.
I hope.
When I'm at home on my other computer, sometimes I accidentally try to zoom in, and it's not touching.
I do that, like, I try that.
I do that on every single computer I use.
Working. Really, Jake?
Yay! He hasn't got punched in a while.
It wasn't actually that hard, it was just where I hit him. Sorry, Jen. Oh, that one was kind of easy.
Did you just slap him in the face?
Yeah.
I barely even touched
I
him.
hit him on the
Now you
shoulder.
start bullying you, Jake.
No, it's
Yeah,
my
you're
job.
okay.
It's getting out of control, people.
I barely even touched you, I'm not apologizing.
Okay.
Punch down in the face on
On accident.
How do you punch someone in the face on accident?
What
It was
numbers were we
supposed to
doing?
be a pretend punch, and I went too far.
Mickey, what numbers did you say? I
2,
know.
3,
Do
4,
number
5,
two.
6.
Yeah, start at 2. I just posted the Quizlet link. And in a little while, Soap's going to explain what she did in terms of translation. Like, derivative equals derivative, and
Derivative equals.
int equals integrate, or something like that, I forget.
Can we use calculators for all of these?
This one, I think you can. I think it's the
Yeah,
first
got it.
two. A graphing calculator is required for these problems.
Good.
These are concrete.
These are top ones, yeah. Oh yeah, look at these horrible decimals here, yes.
What?
posted a new assignment, calc review Quizlet.
Mm-hmm.
Senior.
Right, is that thing that, Esposito just, the packet that we got on Monday?
Yeah.
Well, that's our sad life.
Let's talk to Miss Valley at break so we can adjust our appointment.
Okay. I'll have to call because it's under my name. I hate talking to people on the phone. Freaks me out. I hate talking to people in general.
Okay,
It's such a
Mickey,
big
I'm
deal.
confused.
Oh, yeah.
Mickey,
Mm-hmm.
do we set that equation via t equal to 0, find the correct values and make a sign chart?
No?
Then what do we do?
To take the derivative.
Why would
No,
we
integrate.
But why would-
None of the above.
Right, because it's velocity, that's what you're looking for.
Yeah, you
That's
want
right.
to know when the velocity is going to be
2.
2.
So you said equal to 2?
Okay, yes. However, let's be careful here. It says, find all values in the interval 2 to 4 for which the speed of the particle is 2. What does that mean? What's the difference between speed and velocity?
Velocity.
Velocity
Velocity
is a
is-
vector quantity and has a direction
Has a direction.
That's what I was gonna say.
And the speed is the magnitude
of the,
of that direction, right?
mhm.
So, what we need to do is we need to set this thing, v of t, equal to positive 2
And negative 2.
and negative 2. Because at both of those times, the speed will be 2. Does that make sense?
Alright, guys,
Okay.
so we're on how to solve for t.
So there are a couple of different ways to do this.
Can you plug it into the calculator?
So here's what I would do. I would do, so the velocity is negative 2 plus b minus t cubed. So you graph that one, and you also graph,
Wait, you just graph,
just graph that.
alright,
And then y equals 2, you graph that one, see where they meet.
but I'm gonna write out both equations so they know what I'm doing.
Mm-hmm.
Wait, what do you mean graphing it?
You're gonna,
So,
Like-
I mean, you're literally going to type in into your y editor, y equals negative 2 plus parentheses t squared plus da-da, 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 da-da. You're going to, that's going to go into y1. Into y2 is going to go 2. Because you're trying to find out when is the velocity, which that thing is, when is it 2. So we're just going to find out when those two graphs meet, and that's when it's 2.
No, I just hit the clear button.
I hate that. I know.
First world problems.
Sorry. So you put the equation and then put 2 in for another.
Yes, and see what they mean.
Zero. And you do the same thing on negative 2.
Yep.
Dang,
uh-oh. Oh wait, but it's from 2 to 4, right?
Yes, yes.
So you gotta zoom in.
Now they're looking for precision here to 3 decimal places. Accurate, rounded
Did you say
to 3 decimal
we
places.
do 2 and negative 2? Or
2 and negative 2. Because the velocity is 2. Velocity is also negative 2.
So, for the y equals, we have to do y equals 2 and y equals negative 2?
in my window. 2.
Wait, I'm not even seeing my,
I wonder if the test I took is on here somewhere.
And then how do you like,
why am I?
what is it that you
First
do to
equation?
find the value of the like
Do the intersect. Do
Do
they not intersect between 2 and 4?
Yeah, they do.
Because whenever I put my window at 2 to 4, that graph never shows up. Mm-hmm.
Change your y value.
Negative 2 plus parentheses.
So we find out where it intersects
Yes?
for both 2 and negative 2?
Yep. accurate to 3 decimal places. I'm sorry, what?
Once you get your points,
There you go.
that's it.
That's it. You just need to know the time. Final values of t in the interval 2 to 4, for which the speed of the particle is 2. This is all just calculator work here.
So at 3.128 and 3.473
That's correct.
seconds.
I got 3.255.
3.255,
Yeah.
that is no bueno.
No.
Wait, I'm confused.
Okay. What's going on? Yes.
Everyone's only getting like 2 values.
Yes?
Why?
You're only going from 2 to 4.
I don't get it.
Oh, Jesus.
3.127, 128.
And we're gonna go
Randy?
to,
Mhm.
really?
I'm shedding, I can't help it.
And 3.473.
Big. Right next question is an integral that gives the position. So then you integrate.
So there's x there, and there.
Okay.
Because we limited it from 2 to 4, which is what the problem said. Only from
Okay.
2 to 4.
All right.
Okay, so 3 decimal places, 3.128 or 3.127 apparently they would take, and 3.473. Give them 3 decimal places, they seem to like that. Are we all good on part A? I hope we're looking at part B now. Do we need to talk through it?
Do you integrate it from 0 to 10?
So,
Or not 0, sorry, 0 to 5.
right, but they want you to show a generic integral first.
So they want you
What's generic mean?
So instead of having 0 to a specific number,
to 0 to x.
0 to x, or actually 0 to, not x, but
Infinity?
what, t, why t,
Oh, because that's the
They're
variable
using
using
t.
time.
Okay, so then they want you to do that first and then underneath do 0 to 5?
Yes. So here's what they want you to write. Sorry, Keelan, don't get dizzy. So they want you to have the position. And did they tell you that the position at 0 was 10?
Yes.
Okay.
Do we have to add 10?
Yep. So they want you to have this. S of t equals 10 plus the integral from 0 to t of whatever this is. Is this velocity? Yeah, v of x.
So when it says the position at 0 is 10, that means like that's the water in the barrel?
That's the water already in the barrel. And then S of 5, 10 plus integral of 0 to 5 of v of x dx equals, I don't know, whatever that number is. Right, so here's the generic one, and here's the more specific, and then you actually get the specific value.
And then, so,
So if we just,
so then you just, I integrated from 0 to 5, then you get an equation, so then I got the number negative 450.
is that like, is it 10 plus or 10?
10 plus.
I got
What did you get?
negative 9.207.
That's correct. Negative 9.207.
From 0 to 5
0 to
of
5.
negative 2 times x squared plus 3x to the 6 over
That's
5.
negative 2 plus.
Oh. But then how does it say use the expression to find the position of the particle at time t equals 5?
So the position initially was 10.
Oh, so then the position is negative.
And then we're going to move somewhere, somehow, right? And when we integrate velocity, we get accumulated position change.
Okay, so I got negative 19.27 plus 10.
Yep, which
So-
makes negative 9.207.
S of 5 equals negative 9.27.
So what does that mean?
At 5 seconds, position is negative 9.207.
Yep. And if we were on a number line, it
Do we
would
have
be,
to write that?
nope. Negative 9.207 is good. So if we're on a number line, it would be 9.207 to the left of 0. That would be where the position would be located,
Yeah.
or the particle would be located.
So it's negative.
Okay? Yeah, it's moving backwards. Or left, or whatever you want to say. Yeah, part C.
Changes direction. So then you have to take the second derivative, make a sign chart.
Find all times, particle change direction. When does the particle change direction?
When it goes,
Velocity.
the slope changes.
When the velocity
0.
is 0. Right? The only way I can change direction is if I
Stop.
stop.
So you just set that equal to 0, find
So,
the
so what equals 0?
the velocity.
They give you the velocity function, so set
Can you do
it.
that in the calculator?
Yes.
0 equals, or how do I?
No.
Oh, you just graph it.
Graph it and find the zeros.
Oh, sweet, it's already graphed.
Yeah.
Wow.
How efficient.
Convenient.
I mean, while they do little jerky things in the multiple choice, like giving you parts of your answer that you don't need as multiple choice answers, they do a pretty good job of organizing the process that you have to go through in order to do these free response questions.
And so I'm just writing like graph that and find 0, so that way they know what you did. Instead of writing like using TI-84,
Right.
that's what we.
And you can make a little sketch. Okay, where am I going to get M&Ms or Skittles?
Skittles.
Where am I going to go? In this school in the next 15 minutes.
Ask Miss Sturzo.
Go ask Miss Sturzo, yeah, to be honest.
Really?
Miss Sturzo's the woman.
McD.
Mm.
So I get home last night and I'm like saying hi to my dog and like he jumps up. So I was like bending down,
Bite your face off again.
bite my nose,
Mhm.
starts gushing. So from like this little scratch, literally
In
just
addition to the
down my nose.
half your
Yeah.
face being scratched.
And he like went to go like kiss me, but his front fang hit my nose, like indented
His
it.
front fang.
And oh my
It's a
god,
bad
it hurt
fang.
so bad. I'm like, oh, and then I like stopped, and then I didn't bleed for like 2 minutes, and then all of a sudden, pouring down my face. I'm like, oh, that hurts so bad. Like, get away from me. He's like wiggling to me. I'm like, no, you need to get away from me. I was like,
So it's
He-
0.
he doesn't just wiggle his tail. He wiggles his
Yeah.
whole body. It's like
Okay.
a snake.
Right.
I'm like, oh my god.
Do you have 2 points?
Yeah, I'm just
The
taking
second
a
one, I
lot.
got 3.318,
Yeah. And?
0.536.
Yep. Okay, so that's when it's 0. Does it change? Does it change direction at both of those times?
Yes, because it goes from negative to 0 to positive, and then it goes from positive to 0 to negative.
Boom, boom, boom.
If it didn't go, if it was like positive, then 0, then positive again, does it just mean it stopped?
Yes.
For a second,
So you would have to say,
like Jacob.
therefore the particle changes direction at time t equals blah and time t equals blah.
Changes direction.
And you need to tell them that it changes sign. Changes sign from positive to negative at time t equals blah. Changes from negative to positive at time t equals blah.
Therefore,
Change direction. Woo! Okay, you good?
Woo!
Okay, great. I'll see
See you later.
some of you anyway at whatever's called lunch study.
Bye. See you later.
Advisory. Woo!
My favorite place
Okay.
to spend lunch.
I know. So you think Stirs has
I would
skills?
check her first.
Okay. Hey, you guys are doing awesome.
I usually do, but it's hard to
Thanks.
let you down today.
Especially you, Mark. You're doing the best.
I know.
I've been looking everywhere for this bandana. It's in my bag.
Okay, keep us helpful.
Bye, Keelan.
Yo!
Bye, everyone.
I wonder why the class was quiet.